One of the themes that we saw was that if you try to bite off too much newness, you run into problems that aren't core technology issues, but can still sink a company. Our thesis became a boring systems integration effort to shrink the standard PWR technology.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about a path to commercialization for SMRs. We've explored the technology quite recently. A number of companies have entered the race to build a nuclear power plant using small modular reactors. The key to the technology is a smaller, simpler path to a carbon-free nuclear power. These units can be built in a factory as opposed to on-site, then stacked to add the output of a typical power plant. The biggest hurdle from my conversations with companies in the past is the regulatory review required to permit a unit in the field. In this case, the gatekeeper is a Nuclear Regulatory Commission. Just take an example of one of my previous guests with an SMR technology. In 2020, they announced the NRC had approved their SMR design with a, quote, final safety evaluation report. We covered that in episode 99. It was a historic milestone, but we just learned the NRC's final rule on the design will finally take effect in February 2023. These things take time. It's confusing and tedious, and my guest says they believe their future lies outside the U.S. and the jurisdiction of the NRC. He also says the United States is a bad electric market. For those of us who think new energy technologies can only exist here, be ready to have your minds blown. It's the decision to find friendlier regulators as well as a drive to make the design as quote-unquote boring as possible that's a roadmap for this company to put a simplified SMR out in the field. My guest today is Brett Kugelmass, founder and CEO of Last Energy, an SMR developer based in Washington, D.C. Brett is an entrepreneur who, after his last venture, formed the Energy Impact Center. He says it was through a podcast there that he honed a business plan for their small modular reactors and Last Energy. The company is planning projects in 3 European countries. As we discussed earlier, the regulatory environment and energy markets were big deciding factors. I hope you enjoy my conversation with Brett Kugelmass. We're here with Brett Kugelmass, founder and CEO of Last Energy. And Brett, I try to make it a rule not to interview other podcasters, but from what I read, you came to the solution of Last Energy from doing a podcast. How did that happen?
Yeah, a little bit on my background. Started off as a mechanical engineer, did a master's in robotics. I started one of the earliest drone technology companies. And then when that was acquired in 2017, I formed the Energy Impact Center, focused on energy and climate challenges. We used the podcast as a tool for exploration of a sector, specifically the nuclear industry. Early on, we realized that nuclear was just totally misunderstood, totally under-leveraged. And so the podcast was really a way for us to interview some of the best minds in the industry. And so hundreds and hundreds of episodes later, that helped us form the thesis for what would be Last Energy, the commercial spinoff that builds small modular reactors.
I've done over 150 episodes at this point, and one of the things I can say is that definitely you talk to enough people and you start learning a few things like energy storage and definitely SMRs. So I think anyone who spends a lot of time with this comes to those conclusions naturally.
Yeah, I'd love to hear your perspective on energy storage. What's the latest and greatest there?
I think that there's a lot of things. Of course, there's lithium-ion batteries, but I'm also a big fan of batteries beyond that. I think that you're asking a whole lot of just one chemistry for storage, and I think you're going to need a whole lot more storage than that. But as far as what I guess you would call baseload energy, and especially since the name of the game here is carbon-free, I think the lowest barrier to entry is probably nuclear power and small modular reactors in particular because of all of the infrastructure logistics. That we're seeing, which I'm sure we're going to be talking about. And this is what I really wanted to get to the heart of is it seems to me like there's a large number of developers out there working on SMRs. What do you think sets you apart from that growing number of SMR developers?
The first thing I should say is, yeah, there's a lot of efforts in nuclear, and I am rooting for all of them because this is definitely a rising tide floats all boats situation. Nuclear goes up against so many political and bureaucratic challenges, and there's a lot of different approaches to boil water. It's good that there are a lot of other experiments, and I've learned from many of them. I mean, that was a lot of what the podcast was. We went around exploring, what are people doing and what's working and what's not working, including failed startups like the Empower project and half a dozen others that had taken their shot and didn't make it. And, nothing's ever wrong with the physics. Nothing's ever wrong with a reactor. What we found was that it usually comes down to supply chain constructability, building investor confidence. And one of the themes that we saw was that if you try to bite off too much newness, right? If you try to change the physics or change the chemistry or change the material science or deviate from the standard supply chain, you run into problems that aren't core technology issues, but can still sink a company. And they mostly come down to delivery time, economics, the ability to prove out stakeholder confidence, whether that be governments or investors or customers. And so our thesis became stick to the standard supply chain. Nothing goes in our power plant that isn't currently operating in 100 plants around the world, and really become a boring systems integration effort to shrink the standard PWR pressurized water reactor technology. Basically, the workhorse of the industry that's providing almost 10% of the world's electricity today.
Brett, one of the other things that I've discussed with two other SMR developers, I've had NuScale on, and I recently had Oklo, and both of those companies had endured years of permitting for their reactor designs. This was, NRC permits here in the United States. But you guys have plans to get in the field sooner. Tell us a little bit about how you're planning on doing that. I think that's interesting.
Yeah, so I typically break the government-imposed legal requirements into two categories: nuclear licensing and then local permitting. Nuclear licensing is done at the federal level in practically all countries now. Maybe an environmental agency kicks in. We found that the U.S. not only was not a great electricity market in general, but that due to the myriad of various bureaucratic permitting and licensing issues across this country, that just wasn't a very attractive market at all. And so we looked towards Europe, where the energy demand is a lot greater. Obviously, you can see what's going on there, certainly catalyzed by the invasion of Russia into Ukraine, disrupting the energy markets. But just in general, super high energy prices, super hard to access reliable energy sources. We saw the need greater out there. And so we're focused on three markets: the United Kingdom, Poland, and Romania. We've got some projects picked out, different regions in those countries. And so we go through both nuclear licensing at the federal level in each of those countries, and then we go through local permitting in each of those regions within those countries as well.
So UK, Romania, and Poland, what is their version of an NRC permit? And is it faster to get one?
Faster, cheaper, easier, more flexible. Yeah, I mean, the NRC, while they're great people that work there, don't get me wrong, institutionally, there's a hiccup in that they've never actually seen a nuclear license through from start to finish in their entire 47-year operating history. They've done some license renewals of existing facilities. The Vogtle plant in Georgia will be the first one that they've done start to finish, but that project came just overly cumbersome, overly expensive, overly timely to build, and isn't quite online yet. The other countries that I mentioned, they have different processes, different licensing cultures. For instance, the United Kingdom, they have something called SAPs, the Safety Assessment Principles. And so basically you come to them and you say, hey, here's how it's safe, rather than filling out, a 10,000 checkbox list where even if you've got a great argument as to why a checkbox doesn't apply, it becomes an argument, which becomes $1 million argument, or maybe a $10 million argument, or in some cases, $1 billion argument. It's just a different framework, different paradigm, different way to approach in different countries. And we found those three that we're working in to have a good confluence of factors across both licensing and market appeal, customers, social acceptance, political drive towards more new nuclear. So that's how we ended up in those markets.
I got two follow-ups there. One is you said that the NRC has never approved a permit. Now we're talking about reactor designs, right? Is that what you're saying?
What I'm saying is there's no nuclear installation currently operating in this country under a full license that had its license started with the NRC.
And I'm thinking most recently of the AP1000, which I believe is in the new Vogtle units, right? That is a new reactor design.
It's not online yet. That will be the first that the license application was started under the NRC and will have been issued under the NRC, but it's not online yet.
And then the other thing is you mentioned SAP in the UK as their regulatory body for Romania and Poland. Is there an EU authority, or do they have their own national authorities for these sorts of decisions?
Yeah, nuclear is always done at the national level. There are some rules that might apply across the EU, but there might be some like, hey, we really want you to do this stuff, but they're not hard licensing requirements at the EU level. So it's done at the federal level, and they just have different paradigms, different cost structures, different timelines for issuing a license for your nuclear facility.
Very good. And one of the things I was curious about, Brett, I had to ask a little bit of background because as I was putting together the questions, originally I was thinking the way that you were streamlining a lot of this is maybe you were just pulling a reactor out of, say, a nuclear submarine. And so are these reactors similar to the ones used on, say, an aircraft carrier, a nuclear-powered submarine? I mean, those aren't going to be hundreds of megawatts. It seems to me more about the size of an SMR.
Yeah, they're similar in power output. They're similar in the fact that they have the same moderator coolant, so like water. But the ones that are typically found in naval vessels are much higher enrichment, and ours are just standard enrichment. Our power plant is most similar when you're thinking from like the nautical perspective of the Russian icebreaker fleet that they've built that are just really normal pressurized water reactors shrunk down in size and shoved on a boat.
Yeah. Originally, I thought you were simply using one of those reactors from a nuclear-powered vessel. Do you know why no one's ever tried to just do that?
It's high enrichment, so it's heavily restricted technology when you go to higher enrichment levels, and that's what the nuclear submarines use.
Because there could be a proliferation issue?
That is generally why higher enrichment fuel is not sold commercially.
Gotcha. One of the advantages a lot of these SMRs are being developed is we keep hearing that the ones built from the ground up are, quote, fourth generation designs, which are often synonymous with being, quote, walk away safe. Is your design walk away safe? I know you said you're using a lot of standard designs.
So let me make something super clear. All water-based reactors for all of time are quote unquote walk away safe. All of them. That includes Fukushima, when it melted down 3 cores, it lost every single safety system, including the roof, and not a single person was exposed to an adverse level of radiation. There is no hazard from a meltdown of a water-based reactor, period, end of story.
Yeah. The designs, I guess, that are being built from the ground up, is there any innovation there that maybe you guys aren't using for the sake of being simpler?
Yeah, one of the things that we do to simplify, I'm not going to call it safety, I'm going to call it licensing, like the licensing requirements, is we start off with our reactor buried underground. Once again, I want to make this super clear. When you say I have a safer reactor, it scares the shit out of people, and it's not true. You can't get any safer than not hurting a single person like what happened in Fukushima. But what you can do is design your system to simplify your licensing, to prove certain levels of radio exposure are less than certain thresholds to the regulator. And the simplest way that we found to do that is literally shove it in a giant steel box underground, and that's what we do.
Covered by a bunch of concrete, right?
No concrete, just steel,
Really?
Steel and earth.
All right.
Yeah, concrete is labor intensive. It leads to construction complexity. And at high temperatures, concrete doesn't melt, but it actually dissolves and then breaks apart and sometimes even releases carbon dioxide and then creates pressure environments. So I actually don't like concrete. And so we don't use concrete. We use steel and earth.
Gotcha. So how much modification was needed from a standard reactor design that you started from? What engineering, I guess, did you have to do, and what engineering did you avoid?
If you would think about like what a PC computer is versus a smartphone or a tablet, think about what the re-engineering would be. You're designing a new circuit board, how everything connects together, right? You are going out to the supply chain and picking smaller components, a smaller LED screen, different components. That's what we did. We took the same process engineering, which coolants and chemicals and water and pipes and steam flow from what components to another. Same stuff we took as a PWR. And then we did the systems integration and systems engineering to shrink it down to the 20 megawatt electrical output scale. So it's a lot of work. It's complex. It's power plant engineering, though, so it's nothing that hasn't been done before. And other people could do it too. And we encourage other people to follow in our footsteps. And we've repackaged it into this much smaller envelope. But yeah, not much innovation in the sense of new components or new physics or new material science or new chemistry. None, actually. But a lot of hard work from a technical integration, systems integration perspective.
Brett, I worked at Duke Energy, and when I started there were a lot of people who'd come over from the VC Summer project that they had to abandon in South Carolina. And one of the things that they talked about a lot with that was the fact that they were using 10 CFR 52. It was basically just a standard that everything has to be exactly perfect. So they were turning a lot of suppliers away at the door, things like rebar and whatever. Also, things were expensive because all the vendors basically had to have a serial number that was essentially the same component -N. And that made things a lot more expensive. Tell us a little bit about your procurement process. Are you having to go through situations like that where you're having to get specialized components for your equipment like they were at some of the larger projects?
Yeah, it depends. It's complicated. We go through our power plant, which might have, 100 systems and 10,000 different parts, just using round numbers. Each one of them follows a different code and standards. We have tried to minimize the number of components that are quote unquote N stamped, which means that it has to be a nuclear qualified vendor. But all of our components are commonly found in the chemical and oil and gas industry. And quite frankly, from my perspective, have even a higher standard of quality than those that are specifically nuclear qualified.
Large nuclear reactors at power plants, from my understanding, usually operate about 18 months, and then they take about a month to refuel. How does a smaller unit like yours compare for refueling, and who takes it?
We do a 6-year fueling cycle. We leave it in place, so we don't actually take anything anywhere. We leave the spent fuel in the facility until the end of the facility's life. And then it takes us about 3 months to do our fueling outage. A little smaller than the large scale plants, but they're a lot more experienced and a lot more practiced at getting these things in the fast. Actually, if you've ever been to an outage at a nuclear plant, if you haven't been, you should. It's amazing. Like the coordination, the sophistication. It's unlike anything you've ever seen. I think some of these power plants have done it like 14 days. It's like a beautifully orchestrated dance. It's unreal.
For the record, I did ask to see if I could witness a refueling, and they told me I'd have to get rad tested.
That's okay. It's not that, I don't think it's that hard to get rad tested.
I think that's where they basically said no.
Okay.
To me. I worked in transmission, so it didn't make any sense. It was just a curiosity. These agreements, specifically with Romania and Poland, it's reported that you expect to be operational in 2025. Any other reason why those countries?
We sought out countries first that have all the proper nuclear treaties with the United States. Then we went to places that have like a high energy need, clean energy policies, high power prices, geopolitical stability, political support for nuclear, social support for nuclear, experienced nuclear industry, industrial countries, and those were the countries we ended up with.
I know you probably can't talk about who is your fuel supplier, but given the situation in Russia, is it a supplier that I think would be geopolitically stable?
I can talk about who our fuel suppliers is. There's only 3 out there, and we are working with all 3. KNF, Korean Nuclear Fuels, Westinghouse, and Framatome. These are the only companies that supply PWR fuel that goes into the operating utilities today. And just like with every component in our facility, we have a hard and fast rule. Nothing goes in our power plant unless it's currently operating in 100 plants around the world, and that includes the fuel itself. Standard off-the-shelf fuel from one of those 3 suppliers.
Yeah. Going back to the refueling real quick, it says the idea is that you would probably stack these in a multiple modules per site, so you would probably rotate the refueling cycle. Is that the idea?
Multiple power plants per site. So every single one of our power plants, which has a single reactor in it, is fully independent from every other plant. We only sell one product. It's a 20 megawatt power plant. And so if you want 80 megawatts, you buy 4 of them and you literally put them right next to each other. But they're fully independent facilities without any shared critical infrastructure.
Right. And that's the image I think I saw of it. Looked like about 4 different units, and it was kind of in a cul-de-sac. Right.
Yeah. I mean, we care about design and community support. And so we want it to be beautiful. And we've designed a campus with a beautiful walking path for when multiple units are on site. So it's inviting and like just a nice environment.
I think that a lot of these SMR developers are painting pictures like that, literally. I think Oklo, they've got a very striking design and new scale. The common DNA in a lot of these SMR developers, where they're talking is these sites would be located very close to populations as opposed to nuclear plants, which are on the edge of the county, right at the edge of the reservoir. So is that the idea, too, of getting people comfortable with carbon-free nuclear power near them?
Yeah, I mean, my philosophy is that if you don't want people to be afraid of something, you have to expose them to it. If the real estate wasn't so expensive, I'd put this thing smack in the middle of downtown. It's really just kind of a cost trade-off of where you want to put them. Land prices, access to grid interconnects. But yeah, I think they should be right in the middle of population centers.
Getting back to the NRC one more time, are you planning on pursuing an NRC permit to operate in the United States?
There's interaction that we have with the NRC, but it's not going to be for an operating license, mostly for export and other approvals that they issue, but not for operating a power plant here in the US. It's just not our target market.
So the market is large enough in a lot of these other regions where you may never work towards a permit in the United States. I think that'd be probably a surprise to a lot of folks.
The market's much larger outside the United States. The US is not a good energy market. It's a great market for a lot of things, consumer goods, music, technology, not a good energy market.
To the extent you can talk about it, other than Europe, you never hear about nuclear plants in Africa, for instance. Is something like that possible? South America?
So there's nuclear plants in South America right now, and also in South Africa, there's a nuclear plant. And then there's a bunch of nuclear research reactors spread across Africa. I'm not sure if we want to draw the distinction between sub-Saharan Africa, but Egypt, they're building a nuclear reactor. Algeria has a research reactor. And I'm sure there's going to be a few more power plants throughout Africa as well. Latin America definitely already has them. So they're there. Yeah, maybe just don't hear about them that much, but they're there and it's going to be a growing market. Probably not a market for us, just because we go to where the demand is the highest, where the need is the highest. And right now that's Europe and then maybe Southeast Asia. But yeah, the whole world's going to have nuclear.
Yeah, it sounds to me like your staff's going to probably be boning up on a lot of second languages.
No, it's incredible. Our staff already speaks so many different languages. It's amazing. And then we also have in-country subsidiaries for each of these target markets that are staffed by locals there. But yeah, it's an incredibly diverse, multicultural company. It's awesome.
Very good. Brad, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
I think all fossil technologies have done incredible good towards bringing humanity to our next stage of evolution in terms of curing poverty, in terms of putting food on the table. So I'm a big fan of fossil technology. It's just time for us to transition to the next generation of technologies, which is going to be atomic power.
Crude oil.
Same thing. I mean, listen, I think all fossil fuels have done wonders for humanity. I think fossil fuels are great. They just come with downsides that it's time to move past.
Nuclear, you guys.
Yeah, amazing. It's the future. It's like what every futuristic society is going to end up as almost 100% of their primary energy source.
Coal, and I'll add coal with carbon capture.
Same with crude oil and same with natural gas. I think coal has done wonders for humanity, but it's time to move past it.
Wind.
I like the big wind turbines out in the ocean. It's just a question of like, what is the material input? What is the energy input? And what is the impact on the grid of intermittency that then requires other storage technologies, which also have a carbon footprint? So it has to be carefully balanced. But I think the bigger and taller out in the ocean, the better. I think it's really cool.
Solar.
I started off my career designing solar panels, thin film solar panels from Nano Solar. So I have a great emotional connection to solar, but unfortunately it comes with huge drawbacks, including environmental pollution, material consumption, the intermittency, which wreaks havoc on the grid. So I don't think that there's much of a future for solar, unfortunately, because I still do have a very strong emotional attachment to it.
Biofuels.
What a waste. Just what a waste.
Hydroelectric.
We're all tapped out. Otherwise, once again, it's a great way to like balance the grid, especially energy storage using hydropower is pretty cool.
Geothermal.
Sounds very interesting. I think that there's opportunity there if you dig deeper and if you get the digging technology extremely low cost. But geothermal and nuclear, a lot of these thermal technologies all work fundamentally the same way. And if you can have your hot rock closer to the surface and easier to construct like a nuclear plant, I don't really see much of an advantage in digging deep into the ground, but I think it's cool still.
Energy storage.
Not necessary. There's so much energy stored in the atom already. It's creating more of a problem than it's worth. Though that being said, if we have that problem already, how to balance the intermittency of the energy systems that are already there, we need some sort of storage for what we've already installed, at least for the time being. And I think probably thermal storage technologies that rely on heating up masses are probably more interesting than chemical storage.
Energy efficiency.
I think it's stupid. I don't think we should be efficient with energy. I think we should be cheap and clean with energy and then have so much abundance that we don't have to worry about efficiency and launch humanity into the future where its prosperity is an order of magnitude greater than it is today.
And then finally, fusion power.
I think there's so many misconceptions around fusion. Most people that things don't like about fission are 5 times as bad with fusion. And it's just because we don't have it yet that people don't know those things. Listen, fusion is a type of nuclear. I think it would be a great scientific achievement to show how it works. I think we're going to learn a lot from the process. So I am for R&D funding of it, but I think it's just totally impractical as an energy system because of how much it's going to have to deviate from the standard supply chain and has zero advantages over fission.
All right, Brett Kogelmass, Last Energy, thank you so much for your time.
Yeah, thanks, Jay. It's a lot of fun.
That was Brett Kogelmass, founder and CEO of Last Energy, an SMR developer based in Washington, D.C. I want to thank Brett for his time, as well as Hannah Chabinsky at Last Energy for setting this up. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram at Host Energy and Twitter at Host Energy Cast. All guests are sent the wrong completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 159. Be sure to join us next week when we learn how the biggest hub for lithium might be found in Quebec. Until then, I'm Jay Downhauer. We'll see you next time.